This program will demonstrate how to properly install the Raychem self-regulating heat tracing system, the best system available for controlling pipe temperature. Proper installation of each component will ensure the peak performance of the system. Be aware that some of the components or their parts shown in this program might be different from country to country, so before installation, check your written instructions carefully. Installation instructions are provided with all connection kits and heating cables, as well as on the Raychem HTS website at www.raychemhts.com. First, let's look at the major components of the Raychem heat tracing system and see how they work. The system includes the heating cables, the connection kits, and the control devices. There are 4 types of heating cables that are installed on pipes for temperature maintenance and freeze protection. Each can be configured for use in ordinary or hazardous areas where there is possible exposure to corrosive materials. KTV cable can withstand temperatures of up to 420 degrees Fahrenheit or 215 degrees Celsius. And it can maintain process temperature to 300 degrees Fahrenheit or 120 degrees Celsius. XTV cable can withstand temperatures of up to 420 degrees Fahrenheit or 215 degrees Celsius, and it can maintain process temperature to 250 degrees Fahrenheit or 120 degrees Celsius. QTVR cable can withstand temperatures of up to 225 degrees Fahrenheit or 110 degrees Celsius, and it can maintain process temperatures of up to 225 degrees Fahrenheit or 110 degrees Celsius. And BTV cable can withstand temperatures of up to 185 degrees Fahrenheit or 85 degrees Celsius, and it can maintain process temperatures to 150 degrees Fahrenheit or 65 degrees Celsius. The cable catalog number is printed on the outer jacket of every cable. The first number indicates the watts per foot the cable provides at 50 degrees Fahrenheit, 10 degrees Celsius. Next is the heater type, XTV, KTV, QTVR, or BTV. Next is a voltage rating for the cable. A 1 indicates 120 volts, and a 2 indicates 208 to 277 volts. Most cables have a CT printed on them. CT indicates the cable has a fluoropolymer jacket over the ground braid. A cable printed with an H before the family name indicates that the cable is suitable for Class 1, Division 1 hazardous areas. 20HQ-TV1-CT, for example, is a 20 watts per foot QTV heating cable for 120 volts and can be used in a Division 1 area. Some BTV cables may have CR printed on them. CR indicates that the cable can be used in areas exposed to water or aqueous inorganic chemicals. This diagram shows how a typical heat tracing circuit is laid out on a section of pipe. Power is supplied through the power connection to the self-regulating heating cable that runs along the length of the pipe. The splices and tees are used to connect additional heating cables to the circuit. After the cable end is terminated with an end seal, the entire system is covered with thermal insulation. Power is supplied to the heat tracing system via the distribution panel. This panel contains branch ground fault circuit breakers, which are sized individually for each circuit. In some cases, the panel also contains contactors and temperature controllers. Power is supplied to the panel by a transformer via the main breaker. The electrical design of the system, including electrical protection and circuit breaker sizing, is determined by using the TraceCalc design software or the design guide. Always remember to follow the applicable electrical code requirements when installing the system. Raychem, approval agencies, and national electrical codes all require the use of ground fault protection of equipment for electric heat tracing installations. Also be sure to follow the guidelines of Article 310 of the National Electrical Code if working in the U.S. for branch circuit wiring. There are many types of ground fault protection devices, so be sure to follow the manufacturer's recommended installation procedures. Installing ground fault circuit breakers is a little different than standard thermomagnetic circuit breakers. A ground fault circuit breaker has an electronic circuit that senses a ground fault condition and trips the breaker under conditions that may not trip a conventional overcurrent breaker. It requires that a neutral wire, either run separately or supplied as a pigtail, be connected from the breaker to the neutral bus of the circuit breaker panel. The phase and neutral or phase-to-phase branch wires are landed on the circuit breaker terminals. This ensures the ground fault breaker's electronic tripping mechanism has power to operate. Neutrals may not be shared when using ground fault breakers, so all circuits must have a dedicated neutral. Use equipment-rated ground fault circuit breakers. These trip at a higher ground fault current of 30 milliamps, reducing the likelihood of nuisance tripping. When wiring the system, use a minimum 90 degrees Celsius rated wire for XTV, KTV, and QTVR heater circuits, and a 60 degrees Celsius rated wire for BTV circuits. Before you begin installing the heat tracing system, there are some initial steps that we recommend you take. First, take the time to look over the design drawing so you're familiar with the layout. The drawings will help you verify the actual pipe layout and give you a list of the specified components. If the design drawings are not available or if the design has changed, you can field verify them to create a bill of material. These drawings will help you determine where the heat tracing components should be positioned, as well as verify the quantity of supports, valves, pumps, or any additional accessories you'll need before pulling the cable. Also, confirm that the hydro pressure testing has been completed, and then check to make sure that all piping, supports, and other attached structures are completely installed. Heating cables can be damaged by someone installing a support bracket over the top of them. Next, check to make sure that any newly painted pipe is dry, and be sure burrs or rough edges won't snag or cut the cable. Costly downtime can be avoided by inspecting the cable for nicks and cuts, as well as by checking other components for damage before they're installed. Also, only Raychem-approved components should be used. Substitutions negate agency approvals for the entire heat tracing system. Be sure to check that you have the correct heater cable for the application. Then, conduct an insulation resistance test while the cable is still on the reel. It should register greater than 1,000 megohms at 2,500 volts DC. Record this and all subsequent circuit readings in the installation and maintenance guide. Carefully following these steps prior to installing the heating cable should help eliminate many problems. Before installing cable on the pipe, take a moment to re-verify that the cable you are about to install has the correct rating for the power, environment, and temperature of the application. If everything is correct, mount the reel on a stand near the start of the circuit. This will make it easier to pull the cable along the path of the pipe. Pull the cable the entire length of the pipe to the point where it will be terminated. This is an effective way of making sure that you have enough cable for the entire circuit. As you pull the cable out, loosely string it over any supports. If the cable has to be temporarily placed on the ground during this process, make sure that it doesn't get walked on or run over, which could cause mechanical damage. When you reach the end of the circuit, leave about 1.5 feet of extra cable on the end as a service loop for the end seal. Then, secure the cable to the pipe with tape. The extra cable of the service loop ensures that you'll have enough new cable available if a connector needs to be replaced. When you're installing the cable in a straight line, mount it on the bottom half of the pipe. This protects it from mechanical damage and places the cable closest to the product in the pipe. For installation, start at the end and work your way back toward the reel, securing the cable to the pipe at least every 2 feet with the glass tape that's provided with the heating cable. Use GT66 glass tape for installation temperatures above 40 degrees Fahrenheit, 5 degrees Celsius. Do not use it on stainless steel pipe. Use the GS54 for stainless steel pipe and for installation temperatures below 40 degrees Fahrenheit, 5 degrees Celsius. Use AT180 aluminum tape for plastic pipes and tanks. Install the AT180 tape in one continuous run over the heating cable. Do not ever use masking tape, electrician's tape, metal bands, or wire to attach the cable. They may not have the proper temperature rating, and they could damage the cable and cause a short. As you work your way back towards the reel, you'll need to pull back additional cable to wrap around heat sinks, such as supports, valves, pumps, and gauges. For example, this additional cable has been pulled back to about 3 times the length of this support shoe. This is enough to form these 2 loops, which are then each secured with tape. When you encounter a welded column support like this, first form a large loop secured by tape on the side of the support. Then, wrap the cable around the pipe, covering as much of the pipe as possible next to the support. When wrapping heating cable around valves, the cable length to be used is determined by the thermal design guide for the size of the valve. Wrap the cable around the valve body so that the heat will be concentrated in the area of fluid within the valve. If the heating cable is difficult to install on the heat sink, wrap the extra cable on each side of it. Actuated valves and non-actuated valves each require different amounts of cable because actuated valves have exposed parts that lose more heat than non-actuated valves. The loop for flanges should be 2 times the diameter of the pipe. The extra cable used for flanges and valves not only concentrates more heat in these areas, but also allows the flange or valve to be replaced or repaired without having to cut the heating cable. The pipes leading into a pump and the pump body itself should be traced with the heating cable. Do not mount the heating cable on the motor or coupling. The motor and coupling have no fluid in them and are not insulated. Therefore, they do not require heating cable. There is also a danger that the cable could get tangled in the spinning motor coupling. A service loop here will allow a pump to be removed without cutting or damaging the cable. Applying AT180 aluminum tape for attaching the heat trace on the pump can be helpful. Once you've worked your way back to the cable reel, cut the heater cable from the reel and leave a minimum 18-inch service loop for the power connection. Then tape the cable to the pipe. If the cable will not be immediately terminated, tape a plastic bag over the end to protect it from moisture. Now, conduct an insulation resistance test on the cable again to make sure that the cable has not been damaged. Record the reading in the manual. If the installation has larger diameter pipes or if the system requires redundant cables, an additional run of heating cable will need to be installed. There are 2 methods of doing this: spiraling the cable or using multiple runs. When the design requires the heating cable to be spiraled, install the cable over the entire run of the pipe, attaching it every 10 feet. Your cable should then be hanging in large loops. For example, a heating cable ratio of 1.3 feet of cable for every foot of pipe would require 13 feet of heating cable for every 10 feet of pipe. Tighten the loop of heating cable around the pipe until all of the slack has been taken up. Then tape the final loop in place. Make sure that you trace the heat sinks as previously shown and leave service loops at the end of the cable. Some installations require more than 1 run of heating cable. First, determine whether the additional cable is to supply more heat tracing capability or if it's for a backup system, because each system has a different installation procedure. When installing additional cable for more heat tracing capability, rather than pull cable from 1 reel as we previously saw, you can pull from 2 reels simultaneously to make the job easier. You will still need to allow extra cable from each reel for the heat sinks. However, alternate which reel supplies the extra cable at each heatsink. This will assure that the overall length of each cable will be the same. If you're installing a second cable as a backup system, the second cable will need to be installed exactly the same way as the first. This means that there will need to be extra cable at each heatsink, as well as service loops on each end. If you're using 1 reel instead of 2, first attach the end of the heating cable to the pipe next to the cable reel. Then pull the cable in a large loop down the piping run. As you move, attach one side of the cable to the pipe, leaving the other side loose. Again, leave extra cable for the heat sinks. Also, leave an extra loop from each cable on the serviceable heat sinks, such as valves and flanges. When you reach the end of the run, leave extra cable for the end seal. Then, work the remaining side of the cable back toward the start. Insulation resistance testing should be conducted several times during the installation process. Before installation, while the cable is on the reel, after component installation, before thermal insulation, after insulation, and before powering the circuits. Insulation resistance testing is a reliable indicator of the electrical integrity of the system and should be conducted using a 2500 volts DC tester. To conduct an insulation resistance test of the cable, take the cable from the pipe and strip approximately 2 inches of the outer jacket from the cable. Then pull the braid back. Prepare the opposite end of the cable in the same way. Then attach one lead to the braid and one lead to the bus wire. Make sure that the exposed bus wires and braid never touch each other or the pipe. First, measure the resistance between the heating cable bus wires and the braid. This test ensures that the inner jacket has not been damaged during installation. Next, measure the resistance between the braid and the metal pipe. This test ensures that the outer jacket has not been damaged. A clean, dry, properly installed circuit should measure thousands of megohms, regardless of the heating cable length or measuring voltage. The readings should not vary more than 25% between the 3 voltages measured. If the variance is more than 25%, consult the troubleshooting guide in the Installation Maintenance and Repair Manual to resolve the problem. Before installing the power connections, make sure that you have the proper connection kit for the heating cable. The JBS 100 power connection for a single heating cable, or the JBM 100 power connection for up to 3 heating cables. There are also separate components for LBTV, monitor wire, and Class 1 Division 1 heating cables. Try to mount the power connections, boxes, and drains where they will be accessible but out of the way of foot traffic and equipment. Mount the power connections so that they are not at the low point of the conduit system. Be sure to install the conduit drain provided in the kit. Also, make sure the cable is inserted into the stand before mounting because it's not possible to do so once it's been attached to the pipe. When preparing to make the connection, allow 18 inches of heating cable to make the connection. Cut off the heating cable end at about 45 degrees for easy insertion. With the label on the stand facing the desired position of the box opening, push 12 to 18 inches of heating cable through the stand. Square off the cable end with a 90-degree cut. Do not attach it to the stand yet. When stripping Raychem self-regulating heating cables, you should be aware that conventional cable stripping techniques are not appropriate. Let's look at the correct way to strip a self-regulating heating cable to ensure proper component operation. Before stripping the cable, refer to the kit instructions for the exact length of each cut. These cuts will be different for each component that is connected to the cable. When stripping the XTV CT cable, use Raychem's jacket stripping tool or utility knife to remove the outer jacket, being careful not to cut the braid. Then take an awl and make a small window in the braid and bend the cable. Use the awl to work around the cable and open up enough of the braid to pull the cables all the way out. Then bend the braid back out of the way. Cut away the inner jacket. Then remove the exposed black fibers of the heating element, cutting them flush with the inner jacket. Next, remove the spacer from between the bus wires and trim it even with the jacket. Insert the bus wires into the guide tubes, making sure to seat the core seal onto the cable and remove the guide tubes. Cut the bus wires to the appropriate length. Slide the green and yellow tube over the braid and then trim the braid. On BTV and QTVR cables, strip the outer jacket away and bend the braid back. Remove the inner jacket and cut down to the black core. Cut a notch in the end. Use needle nose pliers to peel back one of the bus wires. Remove all of the black core to expose both wires. Twist each wire. Insert into the core sealer and cut to the appropriate length. Pull the heating cable back into the stand so that 1 inch of the cable is exposed. When fastening the stand to the pipe, use the appropriate number of straps indicated in the installation instructions. Be careful to run the pipe strap under the heating cable. Be sure to tighten the boxes completely onto the stand so that the grommet seals properly. Install the cable ties so the box will not rotate. Use appropriate sized pipe straps. Tape the service loop to the pipe. A small pipe adapter has been included in each kit for use on 1-inch pipe or smaller. This prevents the cable from being crushed by the stand. When all the connections have been made, conduct an insulation resistance test of the cable to ensure that the cable was not damaged during the installation, and record the results. Next, to connect the bus wires and braid to the terminal block firmly, insert a flat blade screwdriver into the square hole to open the spring. The screwdriver will lock into place, allowing you to remove your hand and insert the wire into the round hole. Remove the screwdriver to clamp the wire. If you have a connection kit with a signal light, simply plug it into the terminal blocks before installing the lid. Finally, stow the wires in the enclosure and fasten the lid in place. There are 2 types of kits available for making tees or splices, both above and below the insulation. The JBM 100, which uses terminal blocks, and the T100 that uses crimps, are both installed above the insulation. The S150 is used for splices below the insulation, and the PMK GLT for tees below the insulation. Use the same heating cable prep technique for the T100 and the JBM 100. Refer to the installation instructions for specific details. Once the lid has been tightened onto the stand, install the wires in the terminal blocks provided in the JBM 100. For the T100 kit, install the crimps and the insulating boots provided. Consult the installation instructions for all low-profile kits because they require different stripping dimensions and terminations. Use an end seal to terminate a cable at the end of a circuit. There are 3 types available. Also, preparing the cable for an end seal is a bit different than other connections. To install the E100L end seal, cut the cable end at a 45-degree angle and insert it into the base, leaving 12 inches of cable exposed. Strip back the outer jacket and trim the braid. Remove the inner jacket and core, exposing the bus wires. Pull the cable back into the stand and fasten it to the pipe. Crimp the power wires to the bus wires and slide the core sealer over the cable end. Tighten the light onto the stand. Follow the appropriate instructions for installing the other types of end seals. In many cases, a thermostat is installed to act as a control mechanism for the system. In this program, we'll demonstrate how to install a line sensing thermostat. If you're using a different thermostat or control unit in your installation, refer to the instructions for details about that unit. Before mounting the thermostat, check to make sure that both the voltage and the heater load are compatible with the thermostat, and that its NEMA rating is appropriate for the area of use. Remember, when you're working with any type of thermostat, keep the cover closed to avoid exposure to the elements. Also, refer to the thermostat's wiring diagram to check if it's intended to control the heating circuits directly or to control the coil on a contactor. A line-sensing thermostat is used to monitor the temperature of the pipe on which the heat tracing is mounted. The bulb of the thermostat should be mounted on the bottom part of the pipe, 90 degrees from the heater and at least 3 feet from the nearest heat sink. Tape the bulb firmly to the pipe, ensuring good contact. Also, make sure that the thermostat is mounted so that condensation from the connecting conduit will not drain into the enclosure. Next, visually inspect the system for damage. Inspect all the connections to make sure that the components are mounted securely to the pipe, that the junction box is securely tightened to the stand, and that it's not been damaged. If you find a damaged cable, don't try to repair it. Instead, remove the entire damaged section and splice in a new length using a Raychem splice kit. Once the installation is complete and the system has undergone insulation resistance testing to make sure it hasn't been damaged, the thermal insulation should be immediately installed. Once the insulation is on, check that all valve stems, conduits, connection housings, tubes, and any other devices protruding through the insulation have been weatherproofed. This will protect the insulation from moisture, which could damage the insulation and render it useless. Especially be sure that the cable wasn't damaged during the installation of cladding. Confirm that the cable has not been damaged by testing the insulation resistance once again. Once the integrity of the system has been confirmed, apply electric trace labels on the outside of the insulation at 10-foot intervals. These labels should be on alternating sides of the pipe and should be easily visible. Also be sure to label the locations of all connections such as T's, splices, and end seals. When all the components, insulation, cladding, and labeling are installed, the system is ready for a commissioning test. To perform this test, first, conduct the insulation resistance test of the system at the junction box. Then, check voltage at the circuit breaker panel. Energize the circuit and allow the system to run for at least 4 hours to let the pipes reach a steady temperature. Finally, measure the voltage, amperage draw, and ambient temperature, as well as pipe temperature for each circuit, and record the readings in the installation and maintenance guide. Leave a copy of the guide with the end user. This completes the installation of the self-regulating heating cable, and the system should now operate at peak performance regardless of the weather. If you have any further questions, contact your local Raychem representative. This completes the regular portion of this program. If installing Class 1 Division 1 connection kits, please continue to play the following portion of this tape. There are special considerations for installations in Class 1 Division 1 areas. Explosion-proof power connections, splices, T's, and end seals are required, and these components are installed differently than ordinary area or Class 1 Division 2 components. In the U.S., only HBTVCT, HQTVCT, and HXTVCT cables should be used in Class 1 Division 1 locations. Verify that the heating cable is designated for the area by looking at the printing on the outer jacket. It should have an H as the first letter in the product family catalog number. Also make sure the cable T rating is suitable for classification of the area. This demonstration will install an HAK C100 power connection. Splices, T's, and end seals are installed in a similar way. Consult the installation instructions that come with the kits for installation of all these components. Remember that the mounting bracket and junction boxes are ordered separately. A complete power connection system contains the HAK C100 kit, Universal Mounting Bracket or UMB, JB3 junction box, and pipe strap. Make sure you leave 3 feet of extra cable to make the termination and service loop. To install the HAK C100 kit, begin by installing the UMB to the pipe with the pipe strap. Assemble the half of the compression gland with threaded inserts and the female end of the union to the sealing fitting. Thread the male half of the union into the JB3 box and mount the box to the UMB. Then assemble the union. Cut the corrugated tubing so it's long enough to be taped to the pipe surface when finished. Slide the tubing, its clamp, and the other half of the compression gland over the cable. Select the proper grommet for your cable and slide it on. Slide the cable through the sealing fitting and box so that it extends 20 inches beyond the box. Strip the cable using the appropriate cutback dimensions for the style of core insulator you use. If a heat shrink core insulator is used, follow the specific steps in the installation instructions. In this example, the cold-applied core insulator will be used. Strip the outer jacket of the cable back 14.5 inches. Then, pigtail the braid using the same method as for standard components. Strip off 6.5 inches of the inner jacket. Remove the conductive core or fibers of the heating cable in the same manner as for standard cables. Mark 5/8 inches on the inner jacket as a reference point. Insert the bus wires into the guide tubes, making sure to seat the core seal onto the cable. Slide the green and yellow tube over the braid, then trim the bus wires and the braid. Test the insulation resistance of the cable from bus wires to braid and braid to system ground. Pull the cable into the junction box so the braid pigtail is centered in the large opening of the sealing fitting. Position the grommet in the cavity and tighten the compression gland with the screws provided. Be careful not to change the position of the cable in the sealing fitting. Screw the corrugated tubing onto the gland and tighten it with the clamp. Then, tape the tubing to the pipe. After final insulation resistance testing has been performed, pack the fiber provided into each end of the sealing fitting to form a dam. Mix and pour the sealing compound into the fitting and install the plugs. Then, connect the braid to the grounding bar and fasten it inside the box. Connect the bus wires to the terminal block provided. This completes the installation of the self-regulating heating cable Class 1 Division 1 kit. If you have any further questions, contact your local Raychem representative.